All right, so it says exercise 7 and 8, use the probability distribution to determine A, the number that is most likely to be spun on a spinner, and B, the probability of spinning an even number. Okay, couple things here. If you were to add up all the probabilities, hopefully you talked about this, like the first probability is 1/4. You can see that there. And if you were to add up the second one, which I believe is 3/8, and then 1/8, and then 1/4, you will find that these add up to 1. That's very important here about this one. All right. Is that okay?
I think I did this one, so let me check.
Oh, this is just an aside. This is just a separate piece of information. This is
Okay.
this is just me. Okay. Now for part A, they're not using what I'm used to here, which is the expected value of the variable or the mean. Okay.
Yeah.
And this has a formula. And I guess what I'm not sure of here is, are they just referring to 2 because that is the one with the highest probability, or are they asking for what's called the expected value? And I'm kind of looking for some help here. Do you have the answer to part A to help guide me on what to say here?
Yes, I got 2.
Okay, and so the other way to do this is to take the x value, or the this is probably overly complicated here. You've not talked about expected value, have you?
No.
Okay, so we'll just go with 2. The probability of spinning an even number is probably that x equals 2 or x equals 4. You're just adding up those probabilities. So you got 3/8 plus 1/4, which is 5/8. Is that?
Yes.
That look okay? All right. And do you normally check your answers, when available, with the back of the book?
Yeah, I usually do. And then when we turn it in, he usually goes over it with us.
Okay, and I'm sorry, I just want to make sure, because there's another way to do A. I want to make sure that I'm not giving you bad information. A is for sure 2.
Yes.
Okay, all right. Pretty straightforward here. All right, so again, here's another problem here. Part A is the one with the highest height in this histogram. So 5 is the most likely value in this one.
Yes.
And then part B is probably of an even number. There are no, well, I take that back. The probability that x equals 10, x equals 20. So we're just adding those up. 1/6 plus half of 1/6, which is 1/12. So you got 2/12 plus 1/12, 3/12, which is 1/4, like that.
Yes.
All right. So those are nice, not too bad here. All right. All right, so did you do any coin flipping in class or any sort of exercises in class for this?
We didn't actually do it, but he kind of he went over all of them.
Okay.
We haven't gone over a lot of the answers for this one because I think this one is due tomorrow, so he'll go over the answers, but
All right, like what because my background is in probability and statistics. There's I'm trying not to overcomplicate this, and that's why I keep asking, because I don't want to give you things that you don't need at this point to do these problems. Were you using the calculator at all for these?
oh yeah, because what I did was he taught us on our calculator. You just press 20 math and then go to the probability and do the NCR, and then you plug in whatever number it's giving you. For 9 it would be 1, and then you just press enter.
Okay, so you're using okay, so there is a formula here. Yeah, that's what I wanted to hear. So this is probability that x equals 1. This is considered a binomial distribution, which you don't really need. The number of coin flips is 20. the probability of getting ahead is 0.5 or 1/2. So the probability formula here says that you take 20, and like you said, NCR, 20 choose 1 because X is 1.
Oh yeah, I actually did do this one. Isn't it like times 0.5 to the power of 1 and then times 0.5 to the power of 19?
That's right.
Okay.
What's important though is you know why the numbers go where they go. That one is that one, that one, that one, and then the p-value comes from the head. That's this one on the left, and then this other one is that it's really 1 minus 0.5, which becomes 0.5, and then the 20 is from the number of coin flips. Again, I don't want to get like super formulaic, but
No,
yeah,
yeah.
this is the formula here. So any questions on how to answer that in the calculator? Do I need to show you? Do you want me to check the answer on my side? What would be helpful for you here?
I got like a big number and then it ended with like so something like that. So I just shortened it to like 1.9 times 10 to the -5th.
Yeah, it's pretty small. So there's an obligation here to sort of tell you how many decimal places to round to. This one is extremely small because the on average you're supposed to get about 10 heads when you flip it. So this one is very far away from that. Let me just quickly pull up my calculator, which is different than what you're using, but give me just a moment here to get to that. All right, stat calculators, binomial. All right, so 20.5, we want to get equal to 1. Yeah, so the like your answer there, it's 1, 2, 3, 4, and then 1, 9. So if it said to round to like 5 decimal places, you could get a 2 there, but your answer's fine with the E as is. So I mean, so this formula here is it's 20 choose X times P to the X times 1 minus P to the N minus X is the formula. Or I'm sorry, this
Yes.
is N here. All right, so for the next one here, just have to put the numbers into the calculator here for 10. So for 10, it's probability that X equals 4. So this is 20 choose 4, 0.5 to the 4 power, 1 minus 0.5 to the 20 minus 4 power. This one's a little bit better. If you want to round this to 2 decimal places, please.
I got 0.005 or 46, 0.0046.
Yeah, 0.0046. That looks good. So 11 is probably that X equals 18. So same thing here, 20 choose 18 times 0.5 to the power of 18, 1 minus 0.5 to the 20 minus 18 power.
I got 1.8 times 10 to the -4.
Yeah,
Can you
and
just say that too?
that's correct. Yep, that's good as well. You just gotta make sure you get it. All right, and last one here for number 12 is probability that X equals 20. So this is, every single one is heads, which is pretty unlikely, but you can still calculate this.
9.5 times 10 to the -7.
Okay. All right. So what could happen in a quiz is they might give you a different p-value so that it's not 0.5. They might tell you it's like 0.8, and then you have
Right.
to change this number as well. All of these could change, any of these values, and x, px. So just be aware of that.
Right.
And you said you already tried some of these.
Yeah, I tried 9 and 10.
Great. Okay. So and 13 is
I have
included here.
not done 13 yet.
All right. All right. So here's 13A. According to a survey, 27% of high school students in the United States buy a class ring. You ask 6 randomly chosen high school students whether they own a class ring. Draw a histogram of the binomial distribution for your survey. So here's what you know. You know that P is 0.27. That's the success. Success refers to the thing you're interested in. N is 6 people. Okay, so here's what's needed for a histogram. You basically want to make a table for x, sorry, not n, x, and the probability that x equals x. And x refers to the values of n. So it was up to n, 0, 1, 2, 3, 4, 5, and 6. So you have to essentially do the calculation here for each of these. Okay, now there's a way to do it where you do it in a list and you get all of them, which I could show you, or you could just do them one by one the way we were doing before. What would be best for you?
We can, yeah, that's fine.
Which one? Doing it in a list or doing the calculations each time like we did? So we can use a calculator to do it one time, or we got to do each individual one.
We can just do one time.
Okay, so let me grab my virtual T83 and show that to you. So we are going to be using that formula that I just showed you here. Let me get my calculator up. All right, so new share calculator, there it is. All right, clear. So stat edit, we're going to put this in list one, stat edit, and you're just putting all the numbers in for your x values, 2, 3, 4, 5, 6. You would never do this in real life, but in the classroom, you would certainly do this. Real life, we would use other tools, but this is the one they have used. So very important, when you go over to list 2, you want to go up to the top there, to the header. And the reason is you're going to enter the formula there. Okay.
Okay.
So the first thing is that it's NCR, so it's 6. Okay. And then we have to be very careful because it'll do the whole calculation at once. I'm actually going to put this in parentheses, 6. And then you go back to math and then NCR, enter. And then this time you're getting the value from list 1. So you say second L1, close parentheses.
How did you do L1? Okay.
Yeah, second one gets you to L1. Now the next thing is you're taking that probability, that 0.27 to the power of, and it's L1 again. Okay. And then, and I don't even know if I don't know if we need to put, but I guess I'm going to insert a multiplication here. I don't know if it will just do it. Same thing here. We have a multiplication times, times 0.73 to the power of, and this time it's going to be 6 minus L1. Okay. Now let me know if you missed anything, because once you hit enter, the whole formula goes away. Let me know if I need to scroll back.
No, I think I got everything.
All right, so I'm gonna hit enter. I hope there's no errors. And there you go. So there's all your formulas or your probabilities. So you need all those values. You want to write all those down. I'm gonna do that as well on this other screen.
Okay.
4 decimal places maybe. Just depends on what they want. And then 6 is essentially 0.00004. Okay. Now you can also use your calculator to make a histogram. But I don't know. I mean, that's probably beyond the scope of this course, but that is possible where it draws the rectangles for
Yeah.
you. To do that, let me just quickly show you. Actually, let me take a snip of this in case you want to look at it later. All right, so you go to second stat plot and then hit enter for plot 1. And then see over there on the right where it's got kind of the bars there.
Yeah.
So what you got to be careful here is if you turn this on, you have to remember to turn it off because it'll mess up other plots that you might do. And your X list is L1. Maybe it won't do it. Let me try this. This may not work. I'll come back if it works. All right, so it didn't work. All right, so I take it back. It will not work on here. So I'll go back to the other screen. But hopefully seeing that other part was somewhat helpful. Otherwise, you got to do them by hand. So to do the histogram, you're making boxes. 0 to 1 to 2 to 3 to 4 to 5 to 6, and their heights. The heights are indicated by this here. So you kind of want to be careful here that you don't make them too big. The tallest ones are at 0.33. So maybe make each of these like 0.1, 0.2, 0.3 might be good. First one's about there. Then it's 0.33. Excuse me, 0.31. All right, and then from 3 to 4, 0.15 again. 4 to 5, 0.04. And the last one's basically at 0. Something like that. You should label, X, which is, school rings if you want. And then, no, X is students. I guess it's students with school rings. And then probability of X up here.
Yeah.
All right. B. So part B. We can do part B now that we have all this. Be pretty quick here. What is the most likely outcome of your survey? It's that someone has one school, one of the 6, one student out of 6 has the class ring. It's the one with the highest bar.
That would be 2.
One.
Or is it's
Yeah.
like, yeah.
It's this. There's maybe better way to present.
Oh yeah,
this,
yeah. It is.
It means 1.
Yeah, 1.
Okay, and then. All right. C here. Sorry, got too many things open. Was probably that at most 2 people have a class ring. So at most, and that's what the keyword here is, at most, that's the probability that X is less than or equal to 2. That includes the probability that you get 0 people, 1 person, 2 people. You're looking at the first three values from your table here, the first 3. So if you got those, sorry, I need to go back and forth here. Grab this, it'll help. All right, so that's the 0.1513 plus 0.3358 plus 0.3105. So add those up.
You got 0.7976.
Okay. So, you know, if it was asked, like maybe about 80%,
Yeah.
if that was even needed. So, all right. All right. 14 is really similar. Your book tends to give one problem and then another one a lot like it,
Yeah.
which is what I'm seeing here. So this time, according to a survey, 48% of adults in the United States believing in unidentified flying objects, P equals 0.48, and this time N equals 8. Okay. So again, we need a histogram, which means you have to actually go and make these calculations. Sometimes, I'm going to just show it horizontally this time. Sometimes you will see them written horizontally. So, you know, 0 and then 1 and then 2, 3, all the way out to 8 here. That's another way it might be presented to you. So we will be going back to the calculator. Any questions before I do that?
No.
Okay. So we're going to go back to, and actually, like if you've done this, like we should go to stat plot. Oh, it's off. That's good. If it was on, you might see something at a later time that you don't like. Anyway, so stat edit L1. So you go to end L1 and we start typing in 7 at the end, 8 at the end. Okay. Now, this will clear out, if we just put the calculation in here, it'll clear out list 1. And you don't have to, like we could actually put the calculation list 3, but I'm going to clear out list 1. So to do that, I hit clear up here when I'm at L2, clear, and then enter, and it gets rid of everything. So now we go back, we have to enter the formula here. So that's, and this time it's 8 NCR, and then L1. So second L1, because we want that value from L1, times, this time it's 0.48. I did it differently last time. So 0.48 to the power of L1, and then times 0.52 to the power of, I'm sorry, yeah, to the power of parentheses 8 minus L1. So let me know if I need to scroll back through that. If not, I'll hit enter and we'll get the answer to that. Is that okay?
Yes.
All right, I'm gonna hit enter here. And there they are.
Yeah.
So if you make a mistake, the formula does not appear, so you can't really like read, you can't really like edit it, which is maybe a little frustrating. I was just scrolling down here to get the last few that I didn't get. We get up to 6, so here's 7 and 8. All right, so we can go back to the other screen now, I guess.
Yeah.
All right. So the histogram, you know, maybe to make this clear, like this is 0, this one is 1. Like if I had labeled them in the middle, maybe that would have been clearer. So like the height of 0 is, we'll just do the same thing. So like this one's pretty low. Maybe that's clearer for you that that's 0. And then at 1 is 0.039. So, you know, a little taller rectangle. I don't know. You gotta, whatever your teacher wants, there's a lot of ways to do this. 2 is 0.1. So let's go 0.1, 0.2, 0.3. 2 is 0.127, something like that. 3 jumps up a little bit higher. And then 4.27. So, you know, I'm estimating here. I'm not really getting this. It's not a computer. I'm not going to get it perfect. 5 is back down to 0.2. 6 is 0.09. 7's pretty low. and the last one's basically at 0, something like that. Now, have you seen a normal curve before?
I don't think so.
This one? You seen that maybe?
Probably.
Okay, so the idea here is that the shape of the histogram looks like a normal distribution,
Okay.
which is kind of neat if you're into this stuff.
I'm copying down, finishing the chart. Okay.
All right, so the next two are pretty straightforward to answer here. You slip those in. They all come from the table. So the most likely outcome appears to be 4. X equals 4. Sometimes they want you to sort of specify that in context. So 4 adults in 8 believe UFOs are watching Earth, according to this problem. And then the next one here was probably that at most 3 people. So that, again, probably X less than or equal to 3. You're looking for the probability that X equals 0, plus the probability that X equals 1, plus the probability that X equals 2, plus the probability that X equals 3. There is a way to do this without writing it out. It would be very time consuming if you had to do that for all of them, counting up. But for now, for these, you can just add up those first 4 values in the table there.
Okay. Let me just finish copying that down. Okay. All good.
Okay, so we'll move on to 15. The error analysis. Okay. All right, so like again, the way I recommend doing these is to try to do it without looking at the solution. So we have the benefit of me snipping it in. All right, describe the correct error in calculating the probability of rolling a 1 exactly 3 times in 5 rolls of a 6-sided dice. So there is an N, there's a P, and there's an X. There's a probability that X equals in here. So the N is the 5 rolls. You're rolling it 5 times. You're doing this thing 5 times. The X value is 3. This 1 is actually irrelevant because the probability of any face showing up is exactly 1 out of 6. Does that make sense?
Yes.
Okay. So sometimes they don't give you the thing that I don't want to say it, like you sometimes you have to figure it out. Like each side is 1 out of 6 because they're all equally likely. All right, so then to do this, we know that it's an NCR. It's a 5 choose 3, okay, times the probability to the power of 3 times 1 minus the probability to the power of 5 minus 3. So we know this is correct. We've done this a bunch today. For 15, we now compare, we say, okay, like we look at this, we say, well, what's wrong? You know, what is basically the difference between what you did and what they're giving you here?
Right.
And you can see that they've swapped the exponents here. You
Yeah.
can see that, you know, and I'm not sure how you wanted to note that, maybe say swap exponents or something like that. Does your teacher give you these style of questions on the test?
I'm assuming probably he will.
Okay. Just didn't know if that was a past sort of pattern. These are tough, especially if you don't know whether it's right or wrong. This one's got the right. Go ahead.
For number 15, what was the writing next to it? Sorry.
Oh, swap the exponents. So these are in the wrong position.
Okay. Okay, yeah. Okay.
Now the last one, or 16 here, the exponents are swapped, or I'm sorry, the exponents are fine, they're not swapped, but it's missing the NCR part. So missing the NCR part. And what that is, that essentially is the part where it takes into account the order. What that order doesn't matter, but you got to get all the possible ways that could happen. And that's why the NCR is there. It accounts for that. Because you don't know whether you rolled the 1 the first 3 times, or the last 3 times, or first and then the last 2 times. It takes care of all of that.
Yeah.
All right. Any follow-up from that or any questions?
No, good.
Okay. You're likely moving on to normal distributions, but you could also be at the end of the chapter. I mean, section 10.6, you can't have more than 1 or 2 sections left.
Yeah.
So you got anything else for us to work on tonight?
Well, I think, oh yeah, 7 through 16. Let me see if there's actually, I think there was one question on this other paper that I was really confused on. I can send
Okay.
real quick.
Yeah, go ahead and send it over. We'll work on it.
It's kind of one of those ones where it's like the puzzle time. So if you see like the bottom says like one of the, you know what I mean?
Yeah.
Yeah, so it has the bottom thing, but I think it was number 9 that I was a little confused on.
All right.
So.
Yes, just waiting for something to come in here.
Yeah,
by email.
it's sent just now.
All right. Yeah, it's in the wire. It's a
Yeah.
satellite.
Yeah.
All right, there it is. Okay, so 9, you said 8 or 9, I'm sorry.
Number 9.
Okay. What is probably selecting a 5?
It says, what is the probability of selecting a 3, replacing it, and then selecting a 4?
What is it referring to though?
There's well, I think I sent over 2 pictures, I'm pretty
Okay, so
sure.
it's referring to the other one. I see. So
Yeah,
the
the
number
histogram.
the number selected at random. Okay. All right, that's yeah, it's important. I didn't know if you're this could be a card game.
Yeah, I know.
There's
Yeah.
a lot of possibilities here.
Yeah,
So
sorry. There's a histogram and then it's just
okay.
asking.
Selecting a 3, replacing it, and then selecting a 4. So the first thing you should think about is does one affect the other? Does the fact that you took a 3 affect getting a 4? What do you think?
Does getting a 3 affect getting a 4?
Yes.
Yeah.
So because you're replacing it though, okay, because I think we did some problems last time where it was like a jar of marbles. You know, like let's say there's a blue marble in here and a green marble in here. If you first grab the blue and pull it out, then you're going to grab the green the next time. But if you take the blue out and then put it back in, you could grab the blue the next time. So your probability of grabbing the green is affected by whether you put this blue back in or not. So when you replace something, like think of it as putting it back in the bag, they are no longer, they're not affecting one another. They're now independent. I'm not sure if that was clear or if I need to try something different to explain that.
Could you explain that one more time?
Sure. I think a different example would be good. Also, yeah, let me just quickly like again, let's actually do an example here. So let's say there are 2 reds. Let me do that better. There's a red ball, a green, and a green. Okay. Let's say you first grab a red. What's the probability of selecting a red? There's 2 reds out of how many total in here? How many total do you see?
2.
Total.
Sorry, 3.
3. Okay. So let's assume you got a red, and now what's the probability of getting another red? So assume that one of these is out. How many reds are there in there?
1.
1, and there's two there. Okay.
Yeah.
All right. Now that's case 1. That's scenario 1 where you take one out. Now the next one's, we're going back to the beginning. So, we'll get rid of this little arrow here. We can, there it is. So second possibility, probably of getting a red the first time is 2 out of 3. There's 2 red, 1 green, 2 out of 3, right?
Yes.
You take it out, but then you put it back in. Okay. So now the probability of getting another red is 2 out of 3 because you essentially reset the problem. If they were independent, they would be the same. So in the first one, there was no replacement. The second one, there was replacement. So when there's replacement, it's basically like restarting the problem.
Yes.
But when there's no replacement, it's dependent. Like this answer depends on the previous one, whereas this one does not because you're starting over.
Yeah.
So that what I'm trying to get you to see here is that when you replace something, the selecting the 4 has nothing to do with the 3. The 4 is independent of 3, doesn't, because you're putting it back in. You're putting that number back into the box, if you will.
Yeah.
So what 9 is really asking is just the probability that x equals 4 from this table, which is 0.1. It is in no way affected by the fact that you selected a 3, because it could have said a 3, a 0, a 1, a 2, anything.
Yeah. Okay, that makes more sense.
All right.
Yeah. Okay.
All right. Any other questions?
I think I'm good.
All right. Well, I know you mentioned that this was not your favorite subject in math.
Yeah.
Go ahead and stop the recording here.